you guys know parabolas as y equals x squared. Correct. If it's y equals x squared, what direction is this big old curve going? It goes up like a duck. Okay. You know this because that means the value in front of it was positive. You also knew that y equals negative. I should put that -1 in parentheses. What direction did it go now? Down, up, and round. So depending upon what the value, the leading term coefficient for an x squared parabola, it was either up or it was down. Well, things are about to get real crazy, and your world's going to get turned left and right, because as much as weird as you guys might not know this, there are parabolas that go left and right. I know. So if an x squared parabola went up and down, what direction? What one do you think goes left and right? Y squared. If x equals y squared, it moves to the right. Now, all right, I'll go with this. It moves to the right because if you think about it, numbers that move to the right on the right-hand side of the xy coordinate are all positive. Bless you. And if it was an x, a negative, what direction is it going now? It's going left. So what we're going to do now is we're going to talk about, yes, what is a parabola actually entail? Okay. Now I'm going to go back to just an x squared parabola for a second. And if I draw an x squared parabola, positive, this point is the what? The minimum. More specifically, the ordered pair there is called the vertex. Okay? So the vertex is located there. That parabola opens upward. That parabola is looking at some value floating out here called a focus. If any of you ever done any light refraction, bouncing things off mirrors, or how your eyes work, think about how your eyes work. Your eyes focus on an object because the image is balanced behind you in the retina ball thingy. Cornea stuff, yeah. There's eye stuff. Ojos, dos ojos. See. There's this distance. There's going to be this distance from a vertex to a focus. And then behind the vertex, there will be the exact same distance to what's called a directrix. Okay? THAT. So, direct Rix. Yeah. It's like trying to say that if something's plural with a Z, now we're saying it's X. Thank you. So there is this thing called a directrix. This directrix is the exact same distance away from the vertex as the focus is. So if the distance from the vertex to the focus is 3, the distance to the other one is the opposite direction. It's also 3, but it went the opposite way, it would be negative. Yeah. So we call this value P. This p-value is the distance from a vertex to a focus. What you're looking at. Vertices, if you think of it this way, every conic section that we're going to talk about is going to have a vertex. Okay? If you have a parabola moving upward, that vertex looks at a focus. If it's moving to the right, vertex looks at a focus. We'll get there. Do you wear glasses or contacts? For those of us that aren't as cool and have really crappy eyesight, we have to put things on our eyes, contacts, or we wear glasses to allow the image to be brought into our eyes by changing the distance of where this is, where you're focusing at.
Wait, so can the focus be anywhere?
The focus can be anywhere, and we're gonna.
Does it have to be on the
Yes. And that's where we're getting at. Okay. And this works for all of them, whether it's left or right, up or down. And then when we get into an ellipse is an oval. Okay? These are still vertices, and they're still looking at a focus. Okay? You have a hyperbola. These are still vertices. They're still looking at foci. Okay? That's multiple focuses. Okay? The idea here is that no matter what, your vertex looks at a focus because it wants to see something. This idea of what's called the directrix is the balance behind it. Okay? So P is the distance from vertex to focus. The opposite of P is the distance from vertex to directrix. Okay? Which means that we're going to have to change our standard form of the equation. It looks weird at first, but this becomes super, super simple when we start graphing them. Like Avery said here, she said the focus is always on the axis of symmetry. And I said, yes, all foci will be located on the axis of symmetry of every curve. Whether it is a parabola that's moving up, right, down, or left, they all have an axis of symmetry, no matter what. That axis of symmetry, if it's vertical, is x equals a number. If it's going left and right, it's going to be y equals a number. Okay? Yes, sir? Okay. Nothing rhymes with left. Left, like that. They took away something, which is negative. I like it. All right. Anyway, so we get this. Where you get the formula of the parabolas we're going to look at today are going to be written in the format of y equals 4p x squared or x equals 4p y squared. Okay. Yes, Sam? Okay. When we get going into these, let me pull this part up here real quick. Every one of these, oh, I'm sorry, I had it backwards. It's x squared is 4p1. We'll rewrite. What happens here is that and don't write all this stuff out. I'm just going to show you one of them so you get the idea. When I look at a picture like this, I have a y squared parabola that's positive. That means it opens to the right. All of our vertices today will be centered at the origin, which means then your focus is however many units away. The distance from the origin, 0, 0, to your focus is this value of p. Okay. which means to go to the directrix, it's the opposite of p. You move backwards. And it just happens to be a vertical line. If you have a y-squared parabola, think of the directrix will always be vertical because it's got to touch both parts of it. When you have a directrix for an x squared, it's y equals a number because it should touch both legs of the curve. What happens then, like I was saying, you get these two formulas, y squared for px, or x squared for py. Today, for the next few days, parabolas, ellipses, circles, hyperbolas, we're gonna center everything at the origin. It's easier that way. I might do a little moving things around in circles because I know you've done it. It'll help us see where things are going to go later on. But for now, this is easy. So if you have a positive, it goes to the right, like a kite. It's negative, it goes to the left because of that. It kind of works. Up like a cup, down like a frown. Okay. Those are all things that you know. When we start talking about how do you identify and graph things, that's when we have to do just a little bit of an algebra. And the algebra here is going to be really, really, really simple. Okay. Yes, sir. Glad I can help. Okay. So, let me show you an example. I want to identify the focus, directrix, and graph and label this equation. X equals negative 1/6 y squared. Okay? I want to do everything. I'm going to graph it, identify where the focus, where my directrix is. I don't have to worry about my vertex because my vertex today is always going to be where? 0, 0. So it's no big deal. Yes, ma'am. It was, and I'm going to get to that here in a second. We know that, is this an x squared or a y squared parabola? Y squared. So I know that I need to get it to look like this. Y squared equals 4px. Which means, what do I want to get by itself? Y squared. Okay. How do I move the negative 1/6? Divide by a fraction, which means I'm multiplying by its. So I multiply both sides by -6. Nope. Not dealing with slopes. I'm just doing that. Everybody okay with that? Is it okay if I just flip-flop the order then? So what I'm getting here is then I've got an equation of y squared equals -6x. So it's a y squared parabola, which means what direction does it have to go? Left. It's going to go left because it's negative. So we know that vertex is here at 0, 0. It's got to open to the left, but I need to figure out where is the focus. So this is where that whole 4p comes into play. With parabolas, you're going to get some algebraic statement like this. Y squared equals -6x. That -6 represents the 4p, which means I'm going to solve for p. -6 is playing the role of 4p. Very good. So when I divide it, the distance from my center, my vertex to the focus is -3/2. It's negative, it only means that it's moving to the left. Here-ish. That's my focus. And like you were saying, it's on that axis of symmetry. The axis of symmetry for a y squared is the y equals whatever that vertex value is. I know it has to open that way. I don't know how big the curve is. I don't know how small the curve is, but I know it does something like that. That's close enough. Plug and chugging? Nope. No, with these things, it's more important to identify where things are going. Eventually, you'll understand why they're wider or narrower, and it just depends on how close or how far away the focus is. Not yet. The plot specifically will be when we have a vertex at -2 and 4. And then, what's that? It was, and I just thought of a specific example. Okay. Where does the directrix go then? 3/2 the other way. How do you write the equation of a vertical line? X equals, so the directrix is at x equals 3/2. That's what we're doing today. Identifying the parts, graphing it. The directrix is a line. It's a line, and it's always drawn as a dotted line, whether it's vertical or horizontal. It's because it's a line that's technically not there. It's just there for descriptive purposes. It's like when you draw in the axis of symmetry. You always do that as a dotted line. Same basic principle. Okay? Yes, ma'am. It has to deal with the value. Many, many years ago, a long time ago, in a galaxy far, far away, a bunch of math nerds sat around. I didn't take it. What? Who ratted me out? Anyway, let's try another one. Try another one. This time sometimes does that. No. No. Wait, listen. Somebody uses up, down, left, or right. Which way is this going? Why is it going to the left? Negative. Okay. Where's your vertex? 0, 0. Okay. That means that we have 4px is y squared, or y squared is 4px. Everyone write it. What's playing the role of 4p in this problem? -12. So 4p has to equal -12. What's your value of p then? -3. So your focus is then located at -3 and 0. There's your focus. And then your directrix is at a vertical line, so it is, and then your curve goes like that. Oh, parabolas. All right. Now, what happens if you have this? Write the equation in standard form of a parabola with the vertex at 0, 0, and the directrix at y equals 2. I've noticed that. So, write the equation in standard form of vertex with the vertex at 0, 0, and a given directrix at y equals 2. First thing I would always do with this, exactly, well, sketch it. Because if you think about, know that your vertex is at 0, 0. Y equals 2. Is that a horizontal or a vertical line? Through what number? 2. So I have a. Did I forget the? Oh, it should be a C. Directrix. I didn't realize I spelled that wrong. So I have a horizontal line through 2. What way is this opening? Down. It has to open downward. And why does it have to open downward? Yeah, because the horizontal line above it, bless you, which means this moves down. So if your distance from vertex to directrix is 2, the distance from the vertex to the focus has to go -2. So what's your p-value? It's -2. Your p-value then is -2. Okay? Is this x squared or y squared? Yes, sir. Remember, your directrix is always behind the vertex. So if it's above it, it means it has to go. If you go this way, it's still behind it and it's going to the left. Like do gang signs. This one goes up. This one goes to the right. The directrix always will be behind it. Okay? They're the same distance away. One goes one direction, the other goes the other. So guys, if vertex to directrix is opposite of P, vertex to focus would be P. That's why we know that this has to be a -2. So our p-value being -2, this is x squared. You know it's x squared equals 4py. X squared equals -8y. And that would be the equation. And as you get further along in this, we start shifting things around and moving things back and forth, remembering, like you kept saying earlier, about the whole axis of symmetry thing. Kind of important. Knowing that if your parabola is opening up or down, your axis of symmetry is vertical. If your parabola opens left or right, your axis of symmetry is horizontal. We'll be counting distances. What's wrong, Jay? You're kind of staring at me. You okay? Yeah. Okay. Bye. See what you did there. Okay. Okay. What about this? Write the equation that has, obviously everything's got the origin, so you don't have to worry about it. But the directrix is at x equals 4. The vertex for the next few days will always be at the origin. Vertex is not moving. You will know, trust me, you will know when the vertex moves. Oh, speaking of weird things and things, a lot of formulas and junk, you are not be required to memorize any of these formulas. There's a button for it. It says apps. They're delicious. Just focus on that. Yeah, it was really bad. Anyway, there's a button on the calculator, and I'll show you guys here in a second after we do this example of where we're going to get all of our formulas from. That way you don't have to worry about memorizing them. I don't normally worry about showing you guys that quite yet because those are all going to be the shifted ones, and I don't want to scare you too much. So directrix, x equals 4. X equals a number. Is that a horizontal or a vertical line? That's correct. It's vertical. So vertical at 4. If it's vertical at 4, what direction is this opening? Opens to the left. So if it opens to the left, what's the value of p? Perfect. P value here will be at -4. So left and right, excuse me, left and right parabolas, x squared or y squared? It's y squared, so y squared 4px. My p-value is -4. My final equation is it's the idea, and the idea here is that you have to remember that vertex focus is p, vertex to directrix is opposite. Okay? You're about to ask me something. What do you got? I'm sorry, what's that? No, the formula is 4px. What's 4 times -4? That's where it came from. If this distance was -8, I'd do 4 times -8, whatever that p-value is. Okay? Last one, let's say your focus is at 0, -4. Oh, we just did -4. Oh. If we have a focus located at 0, -7, I want to write the equation of the parabola. Again, we're centered at the origin, so don't worry about that. Rough sketch it, see what we can come up with. What way do I go for 0, -7? So which way is this opening? It's opening down. Remember, you're always going to look. You're always going to open towards the focus. Everything's centered at the origin. So you don't. Yep. If I'm opening towards the focus, what's my value of p? -7. It's got to be -7 because it's moving downward. 4py. This is x squared, just moves down. What's that? I think your final answer is x squared -28. Should not be terribly difficult, in all honesty. Just remember the differences where things go. Real fast before I forget, if you do hit the button on the calculator, there's a button right next to where it says math. It says apps. You should have a whole bunch of different things in there. If you don't, I had somebody during first hour was missing some. Let me know. There's only a couple of these that you'll ever need to worry about for this class. Conics is really the only one. If you hit the button that says apps, and then select option, I don't know what number it is for you guys, mine's 4. There are 4 options for conic sections. If I pull up number 4, that's my parabola again. And right now, these guys, let me pull this on the smartboard so you can see it better. These guys are the shifted version of what we're at. Notice the H and K. There's going to be a horizontal and a vertical shift to all these. Also, notice there's a picture. It's a y squared parabola. This shows you a little picture that means it goes left or right. X squared tells you it goes up or down. Okay? You go to the other ones. You look at ellipse. There are 2 ellipses equations. Obviously, again, these are shifted things. We're not dealing with shifted stuff, so we won't have an H and K tomorrow. But the general principle of that tells you whether or not you are, if your ellipse is pulled left and right, or if it's pulled vertically. And there are going to be some small rules to it. Okay. Anyway, don't worry about memorizing these. Okay. Do these. This really shouldn't take more than 12, 15 minutes, if that. They are really, really fast. Okay? I really hope you don't die 4 minutes into doing these problems. If you do, I will feel bad for about 4 minutes. Just to balance it out so we meet in the middle where the vertex was. You never said it was fun.